Hello viewers, today we are going to start with a new chapter, that is chapter number 3. The name of the chapter is Metals and Non-Metals. See, these metals and non-metals also you are studying since your lower standard. Lower standards means in 7th or 8th standard you have studied about the metals and non-metals, and also you have studied about its general properties. So here in 10th standard also we are going to start with the physical properties of metals and non-metals, by which we can also differentiate between the metals and non-metals. So starting first of all with the physical properties of the metal. So first of all, as you all know that all the metals are having the shining and lustrous surface, right? It is shining, like you can take the example of gold, silver, aluminium, all are having the shiny surface, right? So that is the appearance of the metals. So appearance of the metal is they are having the shining and lustrous surface. Then second physical properties of the metal is they are generally solid in nature. Mostly all the metals found in solid state, but there is one exceptional case is mercury. Mercury is found in liquid state at a room temperature. So whatever the things I have written in the black color ink in a bracket, that was the exceptional case, right? So most of all the metals, generally all the metals found in solid state, but the mercury is the exceptional case which found in a liquid form at a room temperature. Then next is hard. Generally all the metals are hard. You can take the examples of the iron, copper, etc. Right? So they are harder in nature. But there is also one exceptional case is sodium. Generally the metal could not be cut with the knife, but only the sodium is metal there which could be cut even with the knife because it is very soft in nature. So sodium is exceptional case over here, otherwise all the metal are hard in nature. Then after fourth one property is malleable. Now you have studied in lower standard what is the meaning of malleable, that when you are going to hammer any of the metal, when you are going to hammering it would be converted into thin foil. Then that kind of property of metal is known as the malleability, by which we can prepare the thin foil or sheets from the metal, as you are using in your routine life aluminum foil to cover up the food, to preserve the food, right? So that is the malleability properties of the metal, that metal could be hammered and converted into thin foil or sheets, right? Then next, fifth one is the ductility or a ductile nature. Now what is the meaning of ductility? That you can stretch and draw the metal into a thin wire. Then this kind of property is known as the ductility. Like we are preparing the copper wire, right? There are different kinds of wires. Iron also could be converted into a wire, but not that much thin wire. But generally the metal could be stretched and drawn into the thin wires. So that properties of the metal could be considered as the ductility. We all uses the copper wire in our houses for the conductivity of the electricity, right? Then after this, sonorous. Now what is the meaning of sonorous? When the metal is struck with any hard object, it will produce a ringing sound, and that sound and that property of the metal is known as the sonority. As you all know that in our school we are having the bell after each and every period, so that is producing the ringing sound because it is made up of the metal, and when the metal strike with any of the hard object, it will going to produce the ringing sound, and this property of metal is known as the sonority. Now next is all the metals are a very good conductor of electricity, and the best conductor of the electricity is silver, but still we are using copper in the conducting wire because silver is a precious metal, and because of that reason we are not using the silver for the conducting wire, but we are using the copper in a conducting wire to conduct the electricity. So generally all the metals are a very good conductor of the electricity. Then next is the conductor of heat. Also the metals are a very good conductor of heat. See, for all these properties you can perform the different kind of activities which is given in your textbook and we will going to perform in our school, right? For the conductivity of the electricity can perform, you can join the circuit by using any of the iron nail or any of the material which is made up of the metal, and you can see whether the current is passing through that object or not, so that way we can measure the conductivity of the metal, right? Conductance of the electricity of the metal we can measure. Same with the conductor of heat. If you are if you are having any iron rod in your hand and you will start hitting that iron rod at one of the end, then you will feel that at the other end you are not able to hold the iron rod because it is a very good conductor of heat, and that's why it will conduct the heat towards your hand, and that's why you are not able to touch it. So by this kind of activity we can have the idea that the metals are very good conductor of heat also. But there is also one exceptional case is mercury and lead is a kind of metal which is a poor conductor of heat, right? Now as we have seen the third property of metal, that they are hard in nature. So obviously if they are hard, then its melting point is also going to be high, because as you all know the definition of melting point, the temperature at which any substance starts melting, that temperature is called melting point, right? So as the metals are hard in nature, so obviously its melting point is also going to be high, right? So these all are the basic properties, basic physical properties of the metals. Now we are moving to the non-metals. So starting with the first property of the non-metals is they are dull and non-lustrous in nature, opposite to metal. They are dull, like you can take the example of the carbon, sulfur. These all are the non-metals which are having the dull appearance. They are not having the lustrous surface, right? But there is also one exceptional case, iodine. If you are going to see the iodine, I will show you in the lab that iodine having the shining surface, right? So that is the exceptional case in the non-metal. Iodine is a non-metal, but still it's having the shining surface. Next is they are generally appearing in a solid or a gaseous state. But there is also one exceptional case that bromine is generally found in liquid state, though it is a non-metal at a room temperature. And same way, gallium and cesium is a kind of non-metal which is generally solid in nature, but if you are take it in your hand, then by absorbing your palm heat, it will start melting, right? So generally they are in a solid or a gaseous state, but still there are certain exceptional cases. Now third one, it is brittle in nature. Brittle, it means soft. When it will going to strike with any hard object, it will break down into small pieces. So that kind of property is called the brittleness. See your pencil lead, which is made up of graphite, and graphite mainly containing carbon. So it is a kind of non-metal. So as you all know, when your pencil strike with any hard object, your pencil lead will going to be broken down into small pieces because they are possessing the brittle nature. But there is also one exceptional case, diamond. Though the diamond is prepared, the diamond having the main constituent is carbon, it means non-metal, but still it is the hardest object, right? So that is the exceptional case. It is not brittle in nature, it is not soft in nature, it is the hardest material. Next is generally the non-metals are a poor conductor of heat as well as electricity. They are generally poor conductor, but there is also one exceptional case is graphite. If you are taking the graphite lead and you are putting that graphite lead into any holder, then you will feel the current, right? Because it will good conductor of the electricity. So that is the exceptional case in the non-metal. Generally they are poor conductor, but only the graphite is a non-metal which is a quite good conductor of the electricity. And last, as they are soft in nature, as they are brittle in nature, so obviously their melting point is comparatively low as compared to the metals, because they are hard in nature, so they are having the high melting point. As they are brittle in nature or soft in nature, that's why they are having the low melting point. So all these physical properties of non-metals in your textbook has been explained with the certain activities that we are going to perform. So here the physical properties of the metals and non-metals is over. In our next video we are going to see the chemical properties of metal as well as non-metal. So till that, stay safe, stay at your home, and thank you viewers.